probably leave the remaining 20-25 minutes for Q&A, because I think the best way to interact and to learn more is through Q&A. So the agenda that I have for this session is, I'll just give some quick introduction about me, what I do at Mathworks. I'll introduce what is artificial intelligence. Assuming that most of you are from electrical engineering backgrounds, there might be some attendees who might be from computer science and information technology background and may already be practicing artificial intelligence. But just for the sake of wider audience, I'll give a quick overview of what is AI, and then how you can apply these techniques in electric power industry. What are the application areas? And then I'll quickly talk about the differences between machine learning and deep learning workflows. Well, there are so many applications of AI in electric power industry. It may not be possible for me to go over all of them today in this webinar. So I'll quickly touch upon the important applications and workflows and how you can apply these techniques for various application areas. And then if you have any other questions apart from that, you can always feel free to email me or ask me any questions anytime. So just to introduce myself, I'm currently working for Mattworks Incorporated. I'm located in Boston, USA. Before joining Mathworks, I spent several years with an energy company called National Grid, again in the Boston area, working on various project initiatives in the generation, transmission, and distribution areas, protection and control. So, I spent a lot of time in the industry. Before that, I had worked for SR Power at Steel and Cognizant in India. So just to give a quick overview of Mathworks, I'm sure many of you are already using MATLAB and Simulink. So Mathworks is a company that makes the Simulink and MATLAB software. So in this industry, the MATLAB is used for data analytics applications, optimization, algorithm development, a lot of AI application um, development and deployment, whereas the Simulink is more on the model-based design, which can be used for grid integration studies, equipment design, parameter estimation, and optimization. And I'll talk about how you could use both model-based design and algorithm development together in the electric power industry. I think that's one of the key application areas where you may not have data to develop some of these algorithms, and then you can generate the data using model-based design approach. Now, Mathworks headquarters is in Natick, just outside Boston, and we're also present in another 15 other countries. And a lot of AI development takes place at Mathworks. So as you can see, we invest a lot of our profits into technology development. So, before I get into the AI applications, AI has been there for a long time. It's not a new it's not a new technology. It has been used in various other industries for many years, and over the years, the technology has evolved, and the confidence in the technology has grown immensely. In the electric power industry, it's still very early days. People are still understanding how they can apply AI techniques for various applications. But one big challenge is confidence in AI workflows for the applications in the electric power industry. But in many other key areas such as aerospace, defense, automotive, AI has been used for quite some time, and now if you see, many of these technologies have been evolved. So if you're driving a latest car, you have new technologies such as lane detection, pedestrian detection, auto correct, auto steering correct. So these are all the technologies that use AI techniques in them. In the aerospace industry, again, autopilot, mid-air collision. So these are all the technologies that has evolved over many years, and they have improved due to improvement in AI technologies. So while AI is in a very early stages in the electric power industry, as a technology it has evolved, and that gives a lot of confidence to electrical engineers, because electric power industry is a very critical industry. The um, entire any small impact on the grid can have blackout scenarios that we have seen few years back in India, We recently saw a blackout scenario in UK where the entire city of London was blacked out for many hours, and we have had the 2003 blackout in Northeast USA. So you do not want these kind of events to happen, but AI can be a very good technology to adapt for many of these applications, which can prevent from these kind of events to happen. So one question that I asked, I kept people asking me, what are the companies leading uh, technology development in the energy industry? And here I've listed out some of the companies that are kind of leading AI implementation. Many of these companies are located outside India, but you can see Tata. So Tata Power has been one of the leading companies in India that is looking into AI implementation. It's very early stages in Tata and many other Indian companies, but many of the companies across the world are actually leading the way in adopting AI technologies for various applications. And I'll talk about many of these applications that we have worked with these companies at Mattworks. So, in the good thing in the electric power industry is there's a lot of knowledge sharing between companies. So a lot of these companies share knowledge. They put out a lot of press releases of how they have implemented many of these technologies for various applications, which you may not find in other industries such as automotive or aerospace, because those industries are very competitive in nature, and utilities is generally not a very competitive space. People like to share knowledge. So I would recommend that you look for good articles for these companies on how they are implementing these AI technologies for various applications. So I'll show you how an AI works. So this is a very simple application of deep learning. So you can see, you're able to detect patterns. Um, you're able to detect if it's a car, if it's a man walking on the road, if it's an animal crossing the road. So this is happening in real time, and this is one of the applications of deep learning. And we will use this simple concept in many other applications that you can apply deep learning to in the electric power industry. So what is AI? AI is a very hyped word right now. AI, IoT. You know, Essentially, it's working with data and applying different techniques. So AI can be broadly divided into two broad categories. One is machine learning, and the other one is deep learning. So in machine learning, you use both supervised learning approach, or you may use unsupervised learning approach. You also have something called reinforcement learning, which is another aspect of machine learning. And reinforcement learning is good for control-based applications, such as adaptive protection and control. So that's one area which is really picking up in the electric power industry. So, so depending on the type of data that you're working with, depending on how much you know about the data and how much you know about an operation of a system, you can apply different techniques. So machine learning. So what is machine learning? At a very high level. So traditional approach that most of the mathematicians or engineers take is they develop mathematical models. These are mostly handwritten rules or equations, and then basically you apply that to a set of data, and then you get an output, and then you analyze the output of that mathematical equation. Um, it's a good approach, but the challenge is when you have large sets of data, it's very difficult to apply these mathematical models to large sets of data. It becomes very difficult to find out the correlation between the data. Machine learning, you just flip that process. You have a large sets of data, and then you apply it to different machine learning models to find the correlation between the different sets of data. Very simple example, app deployment. People love making apps, and one of the apps that's has become a favorite for everybody is the health monitoring app. Almost everybody has the pedometer app on their phones or on their or on their smartwatches, and they want to track their activity. What kind of different exercises they are doing and how many calories are being burned. They're trying to track your heart rate. So for something like that, you would want to take a machine learning approach. If you're trying to develop mathematical model and you're trying to apply uh, every data captured by every physical activity, it's virtually impossible. So you develop So once you are able to identify data with these activities, then you apply it to a machine learning model, which understands the data and gives you certain output. Learning is very useful when you have um, when you want to scale your application, when you want to adapt with changing data. I think that's where becomes very useful. So as I said, machine learning is used in many industries, and the learnings from these industries can be taken for various applications in the electric power industry. For example, image recognition. I just showed you that's one application that's used in the auto industry. Then you have speech recognition. You have text analytics. Then you can apply. I mean, these are all the different applications that are used in various industries around the world. So how do you apply these techniques to the electric power industry? The electric power system is changing rapidly. Um, Now we are having a lot of renewable sources that are being integrated to the grid, both at the transmission level and at the distribution level. Companies are looking to integrate electric vehicles onto the grid, and these electric vehicles can be in any point on the grid on the distribution system. So that's so these changes are causing a lot of uncertainty. It's also leading to a low inertia grid because a lot of uh, regular generation is being decommissioned. So we have the issues of low inertia, or it might happen in the future. So with all these new technologies that's being generated, a lot of sensors are being installed on the grid, so a lot of data is being generated. This data amount of data was also there previously, but people did not realize the potential that data you can use for different applications. So now this data is in a digital format. Before, people used to record logs of data in paper files, and they would put it in their cabinets. But now, people are trying to use technology to understand where this data is and how you can use this data from the grid to develop various solutions. So when we talk about data, what are the sources of data? People ask, what are the sources of data? The data can be from SCADA systems. PMUs are being installed all over the grid. You have advanced metering infrastructure now. Companies are installing AMIs. You have the energy management systems. A lot of engineers run a lot of simulations, and these simulations generate a lot of data. Energy is traded on the market, so you have a lot of trading data. You have customers using energy, and um, bills are generated with talks, which gives you information on how a specific consumer has used energy. You have data from weather sources. So all this data combined forms the big data in power systems. And right now, the amount of data that's being utilized to understand the behavior is very small. I know there is a lot of untapped potential that we can use with this data to develop various solutions. So what are the I mean, I just talked about the sources of data, but no, what is this data? Uh, what are the possible data types? This data can be from a grid event. It could be data from the transmission grid. It could be data of the transmission line, of the insulators on a transmission tower, different transmission tower itself. Again, data from the distribution grid, data from generators, data on fuel supply, data on consumers. This is a very important source of data. Data from various restoration resources. When workers are on the field, they record logs, they identify problems on the grid, and they record this either digitally or through paper formats. Many of this data is dynamic. They keep changing. It's not constant. Every day is a new day, and you get new sets of data every day. So again, these are all the different data types. These are different data sources. But how do they exist? The data that you collect from the grid could be in various forms. It could be numeric data. It could be data from images. Companies take images of their assets. Companies have been taking images for a long time. They have used um, thermal cameras. They have been using cameras that they fly using helicopters. But now companies are started to use drone technologies to capture images. The other data could be signals from sensors. It could be text data that a lot of linemen record when they are doing surveys. So So you have these different formats of data. The biggest challenge is, how do you combine all of this data into a more readable format that can be used to develop these algorithms? I think that's the main challenge. Developing an algorithm and applying data is not a bigger challenge. A lot of time is being spent on analyzing this data, making this data in a format that can be used. I think that's the biggest challenge. So once you have this sources of data, once the data is collected from these sources, then you can apply that data to different machine learning, deep learning models to do big data analytics. And when I say analytics, I mean analytics is not something new. I mean analytics has been done for many years. People have been doing analytics. We all do analytics. We use different application softwares for doing analytics. It could be MATLAB itself, it could be Excel sheets, or it could be any other softwares. When we talk about big data analytics, the emphasis is on predictive analytics. How can you use data to come up with predictions? I think that's the most important aspect for using this AI technologies. In the electric power industry, like the use cases for AI is along the value chain of electric power systems. Either you're working on a generation side, transmission side, distribution side, or you're trying to analyze data of consumers, or even at corporates. People, especially safety, is a very big aspect in the electric power industry. People who are working on the field, who are working in the site of generators, safety is a big health hazard. People want to make sure that there is no accident, and a lot of analytics is being used to reduce accidents or even minimize them to zero. So I think analytics has use case in every aspect of the electric power grid. And I'll talk about some of this in detail in the coming slides. So, network connectivity. When I talk about network connectivity, transformer is a very important component of the electric power systems. So you have the power transformers on the big substations, where you step down from transmission to distribution voltages, but you also have pole-mounted transformers on the distribution feeders, and all the services that we get in our house, we get it from the pole-mounted transformers. But there are hundreds and millions of pole-mounted transformers on the distribution grid, and many times those are not matched correctly to the secondary distribution network that comes to our buildings, to our homes. So when you have a large outage in a large area, it's important to identify how many people have lost power. In the in North America, you see storms, big storms every year during the hurricane seasons, and storms hit almost the entire U.S. and millions of people lose services during the hurricane season. So restoration is a very important aspect. There are strict guidelines from the government that you have to bring people back in service within 24 to 48 hours after the storm has receded. So the biggest challenge for electric utility is to identify how many customers have lost power, which are the transformers that are out of service. So matching people or consumers with transformers is a very important aspect. So machine learning can be used to identify, which are the mismatched meters to transformers and report any falsely reduced outages, because the crew has to go to those customers and identify if they have lost power or not. And there are millions of customers who are out of power. You cannot afford crews to go to every home. You have to send them to the location which has really lost power. So this is one big application of machine learning. Again, the data that you get from smart meters can be used for such applications. There are companies in India which are exploring these applications in India. So I think it's good to see the websites of some of the state electricity boards or electricity departments in some big cities such as Bangalore, Hyderabad, Mumbai, to see what are they doing in this area. Again, I talked about storms. Again, this goes back to the previous applications. Weather prediction is a very important aspect in the electric power industry. So you want to understand, when a hurricane is going to hit the mainland, what track is going to take place. While weather prediction has made a lot of advances in the recent years, but it's still, there are many unknowns, and utility companies keep a track of these storms because they can change directions very quickly, and they want to identify when a storm hits their territory. which are the areas that are going to get impacted the most. So they want to be prepared in advance. They want to know which are the assets which could get impacted, and they want to restore those assets as early as possible. So damage prediction is a very important aspect. So damage prediction, optimizing your crew placements, and estimating the time of restoration. When you have lost your power at your home, you want to understand when will the power be back in your home. So these are the applications where machine learning can be very useful. Again, asset management. Asset management companies spend a lot of money on managing their assets. These are very expensive, capital intensive assets on the field. A transformer can cost $1 million. Just imagine if there are hundreds of transformers, the cost for these assets can be in billions of dollars. So you want to maintain those assets. Some of the more difficult assets are like underground cables. These are like buried under the ground. It's very difficult to track. How are those assets degrading over a period of time. So lot of money is being spent on asset management. So a lot of machine learning, deep learning techniques can be used to understand the asset health of these assets and also predict when will these assets fail in the future. And once you know that information, you can come up with a better replacement strategy for these assets. You can replace them in the right time, so that you have least interruptions for your customers. So one of the important applications in the asset management area is predictive maintenance of high voltage equipment. So high voltage equipments can be your disconnect switches, it could be your circuit breakers, it could be your transformers, your overhead lines, your underground cables. So some of the equipments are much more easy to manage. Some of the equipments are a lot more challenging to manage. I think two of the equipment which is the most challenging to manage is your transformers and your underground cables. Your transformer is a very complex equipment. While it has been it has been used for many years, still understanding when a transformer might fail is a big challenge in the industry. Similarly, underground cables. You have thousands of miles of underground cables, and these cables are buried under the soil. They could be buried under the river. They could be buried under the sea. So it becomes very challenging to identify which part of the cable has a fault, identify a location. So if you're having a cable that runs through a river of 6 kilometers and you have a fault in the cable, it's very difficult to identify, is it at the beginning of the is the fault at a cable point which is in mid river, or is it more close to the shore? It's very difficult. So I think machine learning, deep learning techniques can be used to identify not just the fault but also location of the fault. So here is an example, that we work with this company called IMCorp in the US to identify uh, faults on underground cables. And essentially, what you see on the picture is you see a cable which has been blown due to a fault. So it's totally destroyed. So when you have data from large number of cables, you can actually use machine learning to look at signal patterns. So there's something called partial discharge. So partial discharge takes place when you have a fault in your insulation. This insulation could be in your underground cables, it could be in your transformers, and it could be in other equipment. So by looking at partial discharge and insulation, you can actually predict if insulation might fail. And if the insulation fails, you basically have a failure of the equipment. So if you see on the left hand side, these are the signals of um, voltages that has been taken during performing testing of underground cables. And essentially what we did was we applied we took this signal waveforms, voltage signal waveforms, and these are like hundreds and thousands of waveforms, and we ran them through um, machine learning models. And you see the waveforms that are in red. Basically, what we did was we used machine learning to identify which are partial discharge signals from these signals. These signals can contain noise. It could have other signal patterns. So you want to detect the right signal pattern, and the signal that we want to use is partial discharge. So once you get those partial discharge signals, then you essentially what you're doing is you're doing feature extraction. You're extracting certain feature types, which is partial discharge. Once you have that partial discharge, you then apply it through a deep learning network. And what we try to do is what we convert a time series data into a time frequency data, uh, which is in the form of images. Once you get images, you can look at image patterns. So if you see here, it's an image pattern, and somebody who's a domain expert in underground cables can look at these different patterns and say if it's a fault due to due to a partial, due to a failure of insulation, if it's a fault due to manufacturing defect, if it's a fault due to defect during installation of cables. So for different faults, you have different patterns. So by detecting the type of fault, you can actually do classification of different types of um, you can do different image classifications to come up with different types of faults. So this is one of the applications. You can use a very similar applications for transformers and for other high voltage equipment. Vegetation management. So vegetation management is very important. You have transmission right of ways. When I say transmission right of way, basically, if you drive down the road, you will see transmission towers. They go through village fields. They go through forest areas. They go through different terrains. Essentially, what the utility do is they kind of clean out the area where they have these transmission towers, and you do not want vegetation to grow near the transmission because it can lead to faults. If you have a windy day, you can have a limb of a tree get uprooted and fall on the three phases or any of the phases of these transmission towers, which can cause issues. So you don't want vegetation to grow near this transmission right of ways. So companies spend a lot of money on vegetation management. Either they install cameras, but you cannot install cameras if you have thousands of miles of transmission right of way. So they do surveys through helicopters, they do surveys through drones, and look for vegetation growth. One thing that the companies have been starting to do is predict the growth of vegetation. 3 months from now, what will be the height of growth of a tree? And when they have a threshold that has been crossed, they want to send the crews and remove the tree or remove the branch of a tree. So those are the applications where you're applying deep learning techniques to look at different images from vegetation and identify what are the patterns, how fast is the vegetation growing, where is the vegetation growing, and then use that to optimize your operations. So that's another application area for AI. I'll quickly touch upon another application, which is energy and price forecasting. So a lot of companies want to predict supply and demand. In when it comes to electric power systems, your supply and demand has to be met all the time. As you know, energy cannot be stored, so it has to be consumed while it's being produced. So that's a big challenge. Now what we are seeing is a lot of renewable energy is being integrated, and renewable energy is intermittent. The wind does not blow all the time. The sun will not shine all the time. So if you have an electric power system which has huge amount of solar um, solar panels, solar plants, in the evening time when the sun is going down, the output of these solar farms can reduce dramatically. So when that happens, it can lead to grid imbalance. So you have to always have enough generation on the grid to meet the load and to maintain a reliable power systems. So weather forecasting can be very important. During a day, you can have a cloud cover, and the output of PV plant can go down. You might have wind blowing at a certain time of the day, and maybe in the other time of the day, you may not have any wind. So these are the forecasting becomes very important. So a lot of machine learning techniques are used to analyze data and come up with forecasting models, both on the generation side and both on the load side. A lot of energy trading companies use machine learning models to predict generation and load forecast because they trade. They want to understand how will the load patterns change at various points on the grid. What are the prices that's going to be at various nodes, and they want to make money. So I think load forecasting and generation forecasting is very important, and machine learning can play a very important role to analyze high frequency data. So these are the applications that I talked about. So you know, there are many challenges in the electric power industry. So some of these challenges are isolated database. I talked about various sources of data and various forms of data. Um, Electric power industry is not your Googles and Amazons where you have all the data stored in a digital format or in the cloud. You know, um, these companies have existed for a long time, and historically uh, they have been capturing data using text formats. They capture this data on paper and they save that data on the paper. They're trying to digitize sort of the way they capture this data, but it's still early days. So a lot of this data is stored in various formats, and that can be a very big challenge to accumulate the data before they can be used for developing these machine learning techniques. um, People do not know what does a fault look like. If you install a new equipment, that equipment might have never failed, so you do not know how does a failure look like. So when you are trying to use machine learning techniques, uh, especially when you're trying to use supervised learning, you do not know how the output is. So when you don't have labeled data, it becomes very difficult to draft some of this machine learning techniques. um, Utility industry is generally very risk averse. They are one of the last industries to adopt any technology. They want to see how the technology has been adopted by other industries, and even in the electric power industry, they want to see how other companies are using this technology. So they're generally risk averse. Shortage of domain knowledge, domain experience, and engineers who have both domain experience and software skills. It's very difficult to find in the electric power industry. Either you have engineers who are very good in software skills, but they don't have any domain expertise, or you'll find engineers who are very good in domain expertise, but they don't have enough software skills. So that's a big challenge. That's a big gap. So you want to find somebody who has both domain experience and software skills to develop some of these algorithms. So I think that's a big challenge in the industry, and I think industry is looking for such kind of people. And I'll talk more about that. And also utility industry, they generally look for more physical products. They want to buy a transformer. Or they feel that if a transformer has failed, that's okay, we'll just replace the transformer. They'll buy new equipment. They don't want to invest in technology. I would not say they don't want to invest because of these challenges. The investment in technology is low. So they prefer buying equipment rather than investing in technology. So these are some of the challenges that people face in the electric power industry. And again, this is the algorithm workflow. So as I said, you have sources of data. You need to have data before you can use the data to develop these deep learning and machine learning models. But these models are good, and they will accurately forecast only when you have good sources of data, or when you have good data. So data preparation is the biggest challenge that any engineers face before they can use the data for developing these models. So data preparation can take almost 70% of your time. And it's most important to invest time in data preparation. So once you have a good data, then you'll have good machine learning models. And when you have good machine learning models, they'll predict uh, the future, or they'll do predictions in a very good high accuracy. So I think data preparation is the most important aspect. So here I touched upon the different applications. So you know to be able to establish a career in this areas, somebody student has to understand what are the application areas, what are the skills required to develop some of these application areas before they can look for careers in those areas. So when you look for opportunities in this area, in this industry, you will find some of these titles. These titles are very common across companies that are hiring people for these application areas. You will see data scientists, you will see software engineers, uh, you'll see electrical engineers, you'll see asset management engineers, because asset management is a very important area. Of course, operations is again a very important area, and I talked about the operational scenarios. You'll find asset operations engineers, you'll find analysts, and this could be in the vegetation management area, or this could be in the operations area, and you'll find uh, uh, operation management engineers who look to develop these algorithms, get insights, and then based on these insights, you want to take certain um, decisions for operations management. So these are some of the career titles that you should look for when you're looking for opportunities in this area. Now, electric power industry is a very growing industry all over the world because there is a push for renewable integration, and as more and more renewables get integrated, the power system will become a lot more complex, and the challenges will become a lot more complex. And you'll also find new challenges in the industry. So eh, companies are always looking for people who can solve these challenges. So it's a very exciting time to be in this industry. One thing that I would want to emphasize. So to be successful in this industry, it is not just important to have either or of the skills. Either you have domain expertise or you have only software skills. You need to have both. I think that's a very important aspect if you want to have a successful career or even get a good career in this industry. You can have either of them and you'll be a domain expert. So you can join a firm only as a software engineer, or you can only join as a domain expertise, but then you'll face challenges when you're developing these uh, when you're trying to develop these application areas. But if you already have some experience um, or some kind of expertise in both of these areas, it becomes much more easy to work in these domain. So I think I would emphasize that while you're in school, while you're in your colleges, try to gain both domain expertise, that is concepts of concepts that is relevant to electric power industry, and at the same time look for software skills that are relevant for these applications. I think that will go a long way. So I think with that, I would like to end my presentation, and I would leave some time for open questions. So Shubham, if you can, if you have already have those questions, please let me know, and I'll be happy to answer them.
Yes, sir. So the first question is posed by Shaharsh Pamecha, and he asks, "What is the most convenient way to convert paper or handwritten data into digital channel for to be used for AI model?"
Yeah, so if I go back to my slide here, there's something called text analytics. Um, so here I talk about text analytics. So I think text analytics can be used to convert a lot of data that's in a handwritten format um, on a piece of paper. And basically, when you run those text analytics, so basically what you do is you scan your document, right? Once you scan this document in a digital format, and then you apply text analytics, you can convert a lot of that data into digital format. So that's one of the techniques that you can use for converting uh, handwritten data into digital data.
Okay, I guess that answers Shaharsh's question. So the next question is, how has the master's degree in business management helped you get an edge in the power and energy industry?
No, so my master's in business management did not help me get an edge in the electric power industry. My master's in electrical power engineering got me an edge in the electric power industry. So, both these degrees are very different. One is for domain expertise in the field of electrical engineering, and one is a domain expertise in the field of management. Having spent a lot of time in the electric power industry working on technical projects, during my career path, I've started to take on more leadership roles. And at that point of time, I decided to do my management degree. So management degree is a different path if you want to choose that. But with my current company where I'm leading this industry, they wouldn't hire somebody who just has a management degree. They want somebody who has a lot of experience in the electric power industry, because unless you don't know the industry inside out, you cannot develop a business strategy for growing that industry. So the business strategy part is more of a management aspect, whereas the industry knowledge is more on the technical aspects. So, and that's where the differentiation is. So I hope I have answered that question. So if you want to gain an edge in the electric power industry, I would recommend to do a more detailed study in the field of electric power systems, which could be a master's degree or a PhD degree.
Okay, sir. So basically, the management degree isn't a prerequisite for the industry.
Not for engineering roles, but once you want to take more leadership roles, once you have gained good experience in the industry, once you know the industry, how the industry works, then a management degree can help you to take the next level of career, which is more on management roles where you're managing a large team. So the important thing to understand is, if you're looking for leadership roles in the industry, if you're looking for management positions where you're managing people, just imagine you're a manager of a group of 10 engineers who are masters and PhDs. If you're not technically strong, you cannot manage them. You cannot answer their questions. So, while a management degree will help you to do people management skills, but your technical skills will help you to answer their questions and lead the team. So that's a very important differentiation. So depending on where you want to go from a long-term perspective, you can either choose to do a management degree or you may not choose to do a management degree. That's one's decision. But to gain an edge in the electric power industry at the beginning of the career, invest in understanding the domain knowledge. I think that's the silver lining, if I may say so.
Okay, sir. Yes. Okay, so our next question is very relevant to the present situation that we are in, and it goes like, how will the corona outbreak affect the power and energy industries in the future, or will it even affect it?
So, one good thing with electric power industry is one of the last industries to get affected because I would say two industries. One is your electric power industry, and one is your medical industry. When I say medical, it's more about pharmaceutical industry. These industries are the least to be affected when you have big financial crisis, because as long as there are people on earth, they will need energy, they will need power. So nobody wants to live in dark. I mean, without electricity, basically your every other industry will be halted. You will not have any kind of economic activity. So electric power industry has to be there to maintain a reliable power supply in the industry. So uh, it's a very good industry to be in, because not just it provides a very stable career path, it's also providing a lot of new challenges which other industries may not face. So for students, when I finished my bachelor's back in 2008, we were going through a very severe financial crisis, and I remember a lot of my friends who just graduated, um, couldn't find jobs, especially who were in the software industry. But people who were working, who were electrical engineers or mechanical engineers, who were entering the domain, who were entering like industries, core industries, if when you say in India, like the electric power industry, or cement industry, and these industries, everybody was able to find a job. So I would recommend that you look to make a career in these industries. They may not be as high paying jobs as your other industries such as software industries, but in a long term perspective, you'll have a better career stability, you'll have a lot of new things to work on, and you'll always have work to do in this industry. So I think you should definitely look for opportunities in the electric power industry.
Okay, sir. So then it's good to know that this industry will not be affected in any time in the soon future. So the next
Yeah.
question we have is by Shreyas Karnik, and he asks is, how important is the academia industry interaction important for an AI application in power industry?
It is very important. So electric power industry, you will find very R&D groups. There are very few companies like ABBs or GEs which has R&D centers, because they make products for electric power industry. But there are very few utilities around the world that invest in R&D, because they buy either they outsource a lot of R&D work to universities, or they outsource a lot of R&D work to companies like ABB and GE and Siemens. So as a student, it makes perfect sense to look for opportunities where some of these companies have sponsored a lot of R&D work to universities. So through that, if you're able to get involved in a project, most likely what happens is these companies hire you because you have worked on a project. So and I came, when I started my career in this industry, that's how I did it. So when I was doing my masters at Northeastern University, my professor at Northeastern was also a professor at MIT. So I started working with him at MIT on a project which my previous company, National Grid, was sponsoring. They were trying to understand what would be the impact of large wind farms on the electric power system. Because I worked on the project for 2 years, I ended up having a job with the same company. So that's a route which I took, and that's a route which many other students take. So I always say, try to look for these kind of academic opportunities or internships that can really help you to gain or start your career in the industry.
Okay, so the next question we have is about your profession actually, and it goes something like, what does your day-to-day activity look like in a worldwide industries manager at Mathworks?
Sure. So that's a very difficult thing to explain because it can take me 30 minutes to explain. But in short, so what I do is I manage the entire business. So Mathworks is a large company. They serve many industries. They serve auto industry. They serve the electric power industry. They serve defense industries. So they have managers who manage this industry. Some of the managers only manage North America. Some may manage only India. Some may manage Asia. But for some industries like the electric power industry, they have one manager who manages the entire industry globally. So basically, what I do is, I work with my teams, which are globally, who are in India, they are in Japan, in Germany, in Italy, in North America. So I work with them to understand what are these companies doing in R&D. So what are the different projects they are working in, and what are their needs? And based on that, we try and come up with solutions that can help these people who are developing R&D into these areas, and how they can use our tools to do R&D. Because when you're doing R&D, you need some kind of tools to perform an R&D. So these companies are looking for new tools, new technologies. So tomorrow, if a company like ABB says, Shishir, we're trying to do this research for understanding failure of transformers, but we do not know where to start with. Can you help us out? So we help them understand how they can use MATLAB and Simulink to develop the technology. So that is on the technology aspect. Many of these companies say, Shishir, I've been using MATLAB, but for this application, I'm not able to use MATLAB because you don't have a function in this, and which is very important. It can cost us millions of dollars. Can you help us developing this technology? And I come back to my company and say, we have multiple companies looking for this technology. Why don't we invest in technology? So then there is a whole technology development process. So that's on the technology side. Then, as a company, we need to grow, we need to make revenues, we need to make profits. So I look at long term strategies. Okay, today where the industry is, tomorrow where the industry will be. So I know this industry has started to invest in technology today, but how much of the technology will be invested from 10 years from now? Which are the areas where this technology will be invested in? uh, how much of revenues can we make in those areas? So I'm looking from a long-term perspective. I'm developing a long-term strategy, and then from a strategy perspective, I'm looking at technology. I'm looking at marketing activities. I'm looking at sales activities. How can I sell more of my products in this industry? Where can I sell them? Who are my people who will buy my products? How do I market my products? How will people understand what we do? Because MATLAB and Simulink is a very complex software. There are so many features, so many functions. Everybody does not know about that. How do I make people aware of those functions? So that's the marketing aspect, and then the technology aspect. What people want, what people want, we should have that in the product. So there is a product aspect. So I look into all of these scenarios. So in short, I'm looking at entire business from a technology perspective and from marketing perspective and from sales perspective. So every continent is different, every company is different. Technology adoption is is an advanced stage in Europe and North America. It's in very early stage in India. So probably where we are in North America and Europe, India will take another 5 years to be there. So based on that, I have to come up with different strategies. I cannot use the same strategy across the world. So I have to understand different markets, and based on different markets, I have to come up with different strategies. So that's what I do in a nutshell. So understanding of the industry is very important. So because I've spent so much time in the industry, I kind of know the industry. Of course, there are still so many unknowns in the industry, and that's what I need to find out. But my experience in the industry plays a very important role. And this is not just for the electric power industry, this is for any other industries. Somebody who's managing an aerospace industry has to understand the applications of AI in aerospace. Somebody who's doing for auto industry has to understand the auto industry. What are the applications in the auto industry? So that's where I'm telling you, understanding domain expertise is very important.
Okay, sir. So the next two questions that we have is more like asking your opinion on these things. So the first one is, what do you think is the future of AI in power systems in India?
It's huge. I think in India is huge, and when I look at different markets, for me, India is a very important market as part of Mathworks. Companies in India are slow to adopt this technology. They're looking at how other companies around the world are adopting this technology. But I recently I was at this India Smart Grid um, conference in Delhi in March, uh, where I met with a lot of engineers, a lot of different companies who are looking to understand how they can use AI. And some of the companies have already started to implement some small projects in AI. So I think the opportunity is huge. Of course, it's going to take some time. It's not like it will happen in 2 or 3 years. It's going to take at least 5, 6 years before technology starts. When people start to adopt technology, they see more value in technology and they start adopting it wide scale. But I think because India is going to be a big hub for renewable energy, India government has already also declared that they want to convert a lot of vehicles to electric vehicles in the future, and these all initiatives will bring a lot of opportunities. So if you're looking for a career in the electric power industry in India, I think it's a great place to be from a long-term perspective. And I think in the next 5, 7 years, AI implementation in this industry is only going to grow. It's going to grow a lot.
Yes, sir. Okay. So the next is what are your suggestions on gaining both domain knowledge and software skills?
Absolutely. So I think I assume most of the attendees here are college students. So you might be in different streams. Everybody may not be in the electrical engineering field. Some of you might be electronics, some of you might be computer science. So I understand that. While I'm trying to focus more on electric power industry, electric power industry is not limited to only electrical power engineers. While majority of the engineers will be electrical power engineers, there are opportunities for other people too. So what I would say, if you're already an electrical engineer and taking courses in electric power systems, then you are at a much better spot, right? So because you are already taking those courses. But if you're not from this major and you want to understand more about how to gain domain expertise, I would say that either you could take classes in your own college r- on topics related to power systems. But if you cannot take that, I think there's a lot of resources available on the internet. I know that working with some of the professors at IIT, IITs have something called I think it's called NPTL. It's a free online resources on various streams, and I think they have a lot of courses, free courses on the electric power industry. So I would recommend to look at those courses, listen to those lectures. If you have opportunities to take classes outside your university, try and take them. So that's on the domain expertise side. I think on the software side, there are a lot of open free resources. Like you could use Google TensorFlow. You could use even Mathworks. If you go to our website, you have a lot of resources on on machine learning, AI, technology adoption, technology learning. And a lot of resources are free, so you can use a lot of these resources. So I think by investing, I mean, the main thing is investing time. If you're able to invest time to gain experience and knowledge in both of these areas over the period of next 3, 4 years, I think it will really help you when you're finally going to graduate.
Okay, sir. Thank you for your suggestion. I hope everyone is going to implement it. So the next question is, sir, what excites you about working in the energy industry? Like as a student, when you thought about this industry, what made you feel like, yes, I want to do this?
I think so. When as a student, I was looking at, uh, you know, I was looking at okay, of course, finding a stable career opportunity is very important, right? I mean, we all want to have jobs at the end of the day. While we all get attracted to the big names such as Google and Amazon, but if that's where everybody wants to be, which is not bad. I'm okay to to look for opportunities in Google and Amazon, but end of the day, everybody cannot find a job with these companies, right? So I wanted to also keep myself open to other career opportunities. And when I looked at the industry, I think electric power industry was one industry which, speaking to many people in the industry, speaking to many of the professors, at that point of time, 10, 15 years ago, um, I concluded that this industry is very stable. Um, this industry will not go through a lot of changes what other industries go through. You know, the tech side there are many startups, but 99% of the startups fail. You're always in a constant um, mental state of mind where you never know what's going to happen 1 year from now, 2 years from now. But with the electric power industry, that's not the case. You people will always need power. People will always need energy, and you always need companies that supply this power. So you'll always have an opportunity to work. So that was one reason. Second thing was, there was all talk about smart grids, smart cities, and India was one country among many countries which are looking into these areas. And when you're working with the electric power industry, you're not limited to only electrical engineering. You also have mechanical engineers, you also have communication engineers who are looking into different technologies. So I think there is no industry in the world which has such a broad range of engineers working for it. So I think uh, these are the reasons why I kind of decided to pursue a career in the electric power industry. Because even if I was an electric communication engineer, I could still find a job in the electric power industry in the communication department. If I'm a mechanical engineer, I can still find a job when I'm putting mechanical structures. So I think it's a very good platform where engineers from multiple streams can come and work together, which you'll not find in any other industry. So I think these were the reasons why I kind of decided to pursue a career in the electric power industry. And of course, I had a personal choice of understanding power systems. I was really fascinated with this big equipments that I see on the field, the transformers, the power lines. I somehow like them, so I wanted to study more about them and see how they operate.
Okay, sir. Good to know. Anyone else in the participants who have a question can raise it by unmuting your mic. So until that happens, sir, another question. Working in Cognizant is really amazing, and how beneficial was the experience for the field of power and energy?
Well, I spent a very small amount of time with Cognizant. I spent like 11 months. So I think so. When I finished my undergraduate, my BTech, I started the Cognizant. I was lucky that I was in a team which was serving the electric power industry. So they were looking for a technology project with the electric power company in India. So I was lucky that I worked on that domain. But again, it was more on the software implementation side, less on the engineering side. So while I got some good insights working for that specific industry segment, it was not core engineering that I was doing. So I wouldn't say that Cognizant has really helped me a lot, and that was one of the reasons why I kind of left Cognizant and I went to pursue my higher studies. One thing I would say, my previous job when I was doing my internship with SR Steel and Power, that's where I actually worked on some real engineering projects. I was at a power plant and I understood the systems. I got to know and learn a lot about power systems during that internship. I think that helped me a long way. So, uh, so for Cognizant, yeah, not much. Hi, you're there. I can't hear anyone. Are there any more questions?
I think we are done with all the questions, sir.
Okay,
Uh, so I guess we'll just end it now. Thank you, sir, for doing this, and I hope everyone has gained some knowledge through this and is going to implement it for their own betterment of careers. So thank you, sir,
good,
and
good.
thank
Best
you
of
for
luck to
everybody
everyone.
for your participation.